So we're going to look at problem number 20 from 7.2. The first part, it says the accompanying data represents the distance feet traveled in random sample of 500 home runs hit during the 2018 Major League Baseball season. There are a lot of parts. Let's take a look at the data. Let's open it in StatCrunch. Why not? All right, 500. It's kind of a big set. The first part, draw a relative frequency histogram of the home run distances using a lower class limit of the first class 310 and a class width of 20. So that's what we'll do. We're going to go to graph, histogram. Actually, wait, did they want... let's cancel that. Let's go to frequency table, because I think from here we could probably get a graph as well. We're going to go with distance. We're going to go with both relative. And then our bin values is going to start at, we said 310, and the width is 20. So let's make it start at 310 with a width of 20. And let's see what we get. Alright, so that's pretty clean. Notice how the upper class width of the first class is the same as the lower class limit of the other. They just do that because the computer just rounds it off. This is a programming error, I believe. But I think if we were to actually graph it and we look at the bins, that they will not have the same value. Now, it didn't graph it like I thought it would, like we wanted it to. So we really are going to have to go into graph then. And we are just going to have to use a histogram. Sample distance. We're going to do the bins again. 3, 10, and 20. Overlay distribution. No. Be kind of nice, but we don't have to do that. So let's just go to compute, and we're good now. So now look, notice how, yep, they're going from 35 to 370, but it's less than 370. And the second class is going from oh yeah, 350 to 370, 370, 390, so on and so forth. So this is really nice. It worked out. The overlay, if we did overlay the normal bell-shaped curve, this thing would be pretty normal. Would have been nice to overlay that. I mean, this is like a nice normal type distribution. They gave us the mean and the standard deviation. The mean of a normal distribution is the one in the middle, and as you can see, in the middle is 400. So I mean, the distribution works out really nice. We got some really high end home runs, lower end home runs, and a lot in the middle. Let's try to answer the question. Draw. Okay, so this was at the relative frequency. Well, it will have the same shape regardless. No, it doesn't look like that. Kind of looks like that. Kind of looks like that one too. Alright. So we basically need our graph up and the histogram up while we check each one. So I think that looks really good. The only thing that I can say that's bad about it is that The only thing we can say is that the scale on the Y just doesn't match properly. But maybe it does. Maybe it does. Let's go. Yeah, let's go with C. No, C wasn't right. All right, let's go back. All right. So the problem is our graph doesn't have the relative frequency. That's the problem. It has the frequency. So let's go back into edit and let's make sure that we're getting the actual frequency. So the height of it with the relative frequencies is the percentage of all of the homers. So over 30% got right around 400, between 400 and between 390 and 410. 30% of all of them. So I think that's going to match. That's going to match the C, choice C. So I'm going to choose that. Okay. Comment on the shape. I'm going to say that it's bell-shaped. Determine the mean and standard deviation. Now we actually have this thanks to StatCrunch. 39.5 and 24.2. Alright, so we're getting through it. Still kind of a long way to go though. Draw the normal curve with the standard deviation found in B on the relative frequency plot. Do you think the normal model would describe the variable distance? Let's take a look. Yeah, I think it would. Do you think the normal model would describe the variable distance? It matches. It aligns. It would. D. Use the mean and standard deviation as the parameters to find the area between 370 and 410. Alright, so we can actually use StatCrunch to do this as well. We're going to go into the calculator and we're going to use the normal calculator. The we need the mean and the standard deviation, so I need to plug that in. 39.5, 24.2, and they want us to find, let's go back, we keep losing that. They want us to find the area between 370 and 410, so we have to choose between 370 and 410. And that's 0.579, and they probably want us to round that to 2 places. .579. So I'm going to do 0.58. The relative frequency, now that's just a matter of going to the bin. The relative frequency for 370 to 409. So 0.24 plus 0.308. 0.55. These values are not close. Oh, and they wanted me to round it 3 places. Oh, crap. They actually are kind of close. I should say they are. Because we know it's a good fit. But it's hard to determine what's good and what's not. I mean, 0.5, 0.58, 0.55, I mean, that's 0.03 off. But we do need to round to 3 places, so I'm going to do 4.8. And then the area there, we have to go back to that piece. And the area is 0.579. They're even a little closer now. Oh, not that close, but let's check. And we got it. Looks like there's one more question. Use the mean and standard deviation as the parameters in the normal model to find the area on the curve to the right of 430. Compare this result with the relative frequency of 430. So they want us to do the exact same thing again. So if I do 430, this is just the standard bell, and we're going to go 430 and up. So I need to switch around this inequality piece, and that's going to be 0.077. And if I were to add these guys up, greater than 430, so we're doing 0.07, 0.0714, 0.0714. So and the other one was, what was the other one anyway? .077. So these are actually pretty close too. Yeah, they are. Well, that's not 3 places, is it? Yeah. 0.071 is now down to 3 places. Maybe 2. Your answers, correct answer. Did I not have 3? Oh, one of them is 0.0877. It point. So okay, I didn't add it right. No, that's right. Yeah, that's too bad. I needed to add all of the bins, the last 3 bins here. So this is 0.07 plus now it's at 804. 0.084, yeah, that's what we needed to put in there. 0.084 would have been good, yeah. All right, hopefully this was helpful.